step is to choose a reference node. That reference node will be taken to be at 0 volt, but it's not at 0 volt. It is relative. We are talking of relative. If Mr. A is 20 years old, Mr. B is 5 years old. When we take B as reference, we consider that B is at 0 year old. How old will be Mr. A relative to Mr. B? Then that Mr. A will be 15. By that 15, look, there's what we call the absolute age. The absolute age of A is 20 years. The absolute age of B is 5 years. But we're going to take B as reference. Whenever we take as reference, we assume it is 0. And if it is 0, Mr. A will then be what? Relatively, it will be 15. It will be 15. If somebody is, Mr. C is 1 year old, that means Mr. C will be minus 4 years old relative to. So this voltage we are talking about is relative to each other, not the absolute voltage. So we are going to take one node as a reference node, and we are going to assign it a nodal voltage. We are going to assign it what? Nodal voltage. Nodal voltage means the voltage of the node relative to the reference node. For the reference node itself, the nodal voltage is going to be taken as 0. And we are going to put a sign of hertz at that, whichever one we have chosen. You are free to choose any of the nodes, but common sense and methodology advises that the resistor of your interest, pick one of the nodes close to it as your reference node. The reason why I ask you to do that, you are going to know it later. Pick one of the nodes that is close to the resistor of interest as your reference node. The reason you are going to know as we go ahead. So let me take this as my reference node. So I'm going to put this sign there, meaning that's the reference node. Let me call it R, reference node. Then the other ones, I'm going to label them V1, V2, V3, V4, V5, V6. You know, I have 7 nodes. I've taken one as reference node, then it's going to remain 6. I'm going to give them nodal voltages. So this means this node 1, it is V1 relative to the reference. It doesn't mean that its voltage is actually V1, but V1 relative to R. Now, if you want voltage across any branch, just check the 2 nodes. For example, now across this branch, the voltage across it is actually going to be either V1 minus V6 or V6 minus V1, depending on which one is greater. It can be V1 minus V6 or V6 minus V1, the voltage across this. The voltage across this is going to be VC minus 0 because it's connected between this. So that's one of the reasons we ask you to choose the voltage here as a reference. So we're only going to be looking for V6. But if you choose this one as a reference node, you're going to be looking for the voltage here and the voltage here to determine the current here. So it is wisdom for you to choose one of them as your reference node. Now, so having chosen your reference node and your nodal voltages, the next thing is now to start writing equations. First, check the voltage sources. For example, this voltage source, 9 volts, is connected between V6 and V5. You know that this point and this point are the same. So this voltage source is connected between V6 and V5. And from the way it is indicated, this end is supposed to be more positive than this. That means actually V6 minus V5 must be equal to that EMF. Hello? V6 minus V5 must be equal to that EMF. So on your own, you can write the same thing for the 7 volt source. you expect that it is connected between V3 and V4. And from that indication, V4 is supposed to be more positive than V3. So we can say that V4 minus V3 must be equal to 7 volts. Now, what we need now is V6. Yeah, it's only V6 we need. If we need the current across this resistor, so we are looking for V6. We are going to eliminate 3 voltages. So let me make V5 the subject of the formula here. So V5 is going to be equal to V6 minus 9. That's my equation 1. I can make any of the subject here. Here I cannot make V6 the subject because I don't want to eradicate, I don't want to eliminate V6. That's what I'm looking for. Let me make V4 the subject here. This will be 7 plus V3. That's equation 2. So the next thing is now that I will try to find at every junction now I can now try to write KCL. I have 6 unknowns. So I need 6 equations. Already I've generated 2, remaining 4. So let me choose at this point. Let me choose KCL. KCL at node 6. KCL. The way, okay, no, let me choose node R at node R. At node R. Now, if I choose that, let me indicate that all the currents are going away from that junction. There are 3 currents. If all the currents are going away from that junction, then the sum of the currents will be equal to 0. This is just a symbol. It's not that any current is coming here. It's a symbol that is the reference node. Now, the way we normally treat this is that this current is going between this and this. It is assumed that it is the reference node that is forcing current against this. So that current is going to be indicated as 0 minus V2 over 6. The current in this 6 ohm resistor, from that arrow I've given, that's where the current is going like that. I don't know where the current is going. That arrow is a guess. And so I want to use that. The 3 currents are going away, just a guess. And finally, you may see that they are not going like that. It doesn't matter. You understand? So this will be like 0. It's like this 0 that is forcing current against this. So it's going to be 0 minus V2 over 6. Plus, this other current is going to be what? 0 minus V6 over 3. This other current is going to be what? Plus 0 minus V5 over 4. And the total current must be equal to 0. Since the 3 currents are going away. Now multiply through by 12. If you multiply through by 12, what you have? This will be minus 2V2 minus 4V6 and then minus 3V5 equals 0. Let me try to get rid of V2. From here I can say that multiply through by minus, which means it becomes plus, plus, plus. Therefore, V2 is going to be half into, it's going to be, this one will go to the other side, it's going to be minus 2V6 minus 3 over 2V5. I have an expression for V5, which means I can rewrite that equation. Let me substitute for V5. That means, what did I write here? V2. That means V2 is going to be minus 2V6 minus, if I'm not, I have V6 here, 3 2 times V6. That would be minus 3 over 2 V6 minus 3 over 2 V6. Then I have minus 9. Minus 9 times minus 3 over 2. That will give me what? That will give me minus 27 plus 27 over 2 plus 27 over 2 v what? Sorry, plus 27 over 2 because this is just an ordinary figure. So from here, I can rewrite that expression to mean what? To mean that V2 equals, this is 2, that will be like minus 7 over 2 V6 plus 27 over 2. Let's keep this. This is my equation 3. Hello, let me divide this my page. This is my page. This is yet another page. So this is my page 1. That's my page. This is my page 2. So I have 3 equations now. It remains 3 equations. Please help me write these equations down. That I have that V5 equals V6 minus 9. V4 equals, let's pause this video here. Let's pause. So we have written these 3 equations down. I will now clean the board to take more equations. Or maybe I should still leave the equations on the board. Let me still leave the equations on the board. Yeah. That is that. So let's now look at another junction. Let's pick this junction. KCL at node 2. Let me assume that these 3 currents are also going away. Let's assume that 3 currents are going away. So that means when we add the 3 currents together, it will give me 0. For this current, V2, for V2, we can take it as V2 minus V3 over 2. It is like, it is node 2 that is forcing current against node 3. So for this one, it is like, it is node 2 that is forcing current against the reference node. So that will be V2 minus 0 over 6 plus this other current this is a current source and it is running against this current source. That means it's going to be minus 5. This will be equal to 0. Get it clear? You understand me? This current that I say is going this way, but it should be related to 5 ampere, like going the opposite. So it must be equal and opposite to it. Another way to see it is that you can say these 2 currents, they are going away. This current is approaching, isn't it? You can say the 2 is equal to plus 5. But when that plus 5 move there, we are saying the same thing. We are saying the same thing. So now, so let me multiply through by 12. If I multiply through by 12, what am I going to have? I'm going to have, I can multiply through by 6. I'm going to have 3v2 minus 3v3 plus v2 minus times 6, right? Yeah. Minus 30 equals 0. So this is like minus 3v3 plus 4v2 equals 30. Let me substitute for v2. Let me substitute for v2. That means minus 3v3 plus, I have to multiply this by 4. So that will give me minus 14v6, then plus by 4, that 54 equals 30. Let me check again. Multiply this by 4, that will be minus 14. Multiply this by 4, that will be 54. So from here, minus 3v3. Which voltage have we not eliminated? V1 was not V1. So let me add 0 V1. Even though V1 is not showing up here, let me write 0 V1. And then for V6, what am I having? Minus 14 V6 equals minus 24. This will be my equation 4. One of the equations we are going to use for the Cramer's rule. So let me write this equation down. This is one of the equations we are going to use for the Cramer's rule. Now, so let me go for another node. Let me choose this node. Have I chosen this? Okay, let me choose this, P6. Let me choose P6. At node 6. Let me choose node 6. Let me clean this. Let me still retain these equations there, even though we are breaking it down. Let me retain it on our board. Now, at node 6, our 3 current. Let me assume that the current is going like this. The current are going away. I like that approach. So I will add the 3 together to give me 0. For this current, it is easy. It is V6 that is forcing current against V1 divided by 1, which is the resistance. Plus this one, it is V6 minus 0 divided by 3. It is V6 minus 0 divided by 3. But for this one, there's a problem. There is no formula to find the current through a voltage source. So what I can do is that I know this current is going to be, this same current is going to be this plus this, according to Kirchhoff current law. The current I need is going to be equal to, let me call this one Ix, let me call this one Iy. The current I need is actually going to be equal to what? Ix plus Iy. I don't have a formula to calculate this. So I have to come to a conclusion that this current will be equal to the sum of this and this. Even this self will be equal to this and this. This will be I1, I2. So that Ix, there is no way I can calculate Ix. But Ix is going to be, so I can say that this is V6 minus V1 over 1 plus V6 minus 0 over 3. That Ix is going to be what? I1 plus I2, and Iy is there. Hello? Hope we are together. Now, so sorry, I had a problem, and that's the way out of that problem. Because there is no formula to find the current through a voltage source. You only have formula. There is also no formula to find the current through current source. You are normally given. That was not a problem because you are given in most cases. So, but for voltage source, there is no way I can know the current. So I will rely on the fact that the current here will be equal to the current here and the current here. That's why I wrote Ix plus Iy. Ix is another problem. There is no way by which I can find the current Ix. But I rest on the fact that it will be equal to the sum of this and this. So now I can now do business. This is V6 minus V1 over 1 plus V6 minus 0 over 3 plus, what will be I1? I have a formula for that. That will be V5 minus 0 over 4. I hope we agree with this because I1 is flowing. So this V5 forcing current against that. I2 is what? V5 minus V4 over 5. And the Iy is what? Is this point is V5. I've told you before. This point and this point. So this is like V5
minus V4
against V4 minus V4 over 1 equals 0. Multiply through by what? Through by 60. Am I right? Yes. 60 should be able to do it. This will be like 60 V2 minus 60 V1 plus 20 V6. This is 15 plus 15 V5 This is 12, Abi.
Yeah.
Plus 12V5 minus 12V4 plus 60V5 minus 60V4 equals 0. Hello. Let me clean up here. We have all gotten here. Let's do the expansion. Let's do the expansion. Now, what V do I have there? I have, let's start with V1. I have only one, Abi. Minus 60 V1. Let me move to V2. I have 60 V2. That's all right.
Yes, sir.
But I have V2 here. I have V2 there. Multiply, which I'm going to multiply by 60. So that will be like multiply by 30. That will be like, it is minus. So this one becomes plus. Plus 30 times 7. That's 210. 210 V6, right?
Yeah.
This will be 30 times, this will be 15. So sorry, that will be 30 times 27.
Yes.
What are you going to have?
30 times 200. That's 600. That's times 7. 210. That's
Calculator is there.
If you are multiplying by, maybe you have calculator now.
I think it's 8 10.
So that will be 30 times 27.
7 times 30. 8 10.
What is it?
8 10.
Plus, that will be minus now.
Yes.
Minus 8, 10. Because there's minus. Oh no, it's plus. Oh. So this should have been minus 2. This should have been minus, and this should have been plus. I move to, there's another V6. How many V6 do you have there? Only one. Plus 20 V6. For 15, for V5, I have 15, I have 12, that's 27, I have 60, that's 87. 87 V5, right?
Yes.
If that's 87 V5, I have V5 here, that would be 87 times, this would be 87 V6 minus,
7 8
minus, as you multiply it,
Yes.
783. Okay, thank you. Then Avanso remain. Okay, I have minus 12V4 minus 60V4. That gives me minus 72V4. Minus 72V4. That will be minus 72V3. If I multiply this by minus 72.
Yes, that's 504.
And that's
minus 504.
minus 504 equals 0. Now help me. For V1, I have minus 60. Let me remove this. For V1, I have minus 60 V1. For V3, what do I have? I have minus 72 V3, right? Huh? What do I mean? What do I have there? Minus 60 V1. Thank you very much. Minus 72 V3. You know, you see the reason why I should be with somebody in this studio. This is my studio. Student, I hope you are not laughing at me. Oh. This is my studio. So, now this is minus 72 V3. Then for the V6, I have minus 210. I have plus 20. I have 87. I have minus 72. I have how many of them? 1, 2, 3, 4. I mean my calculator now. Minus 210. Oh, there's no 72 there.
Yes.
There's no 72 there. Thank you. I have 87, 20. What am I going to have?
Minus 103.
Minus 103 V6. And then equals, for the constants, I have 810. I have minus 783. I have minus 704.
Minus 783.
Minus 504.
Minus 504. That's minus 470.
minus 477.
To be plus now.
It will be
To plus
now, okay.
477.
Plus 477. This is my equation 5. Let me also keep it here. Sorry, I'm too much possessive. I don't want to lose any of my equations. I'm keeping them in view. I'm keeping them in view. So, now, the next thing I'm to do is to take another junction. Can I take this junction? Let me take this junction. Let me say this current is going away, this current is going away, that current is going away. So the three currents will add up to 0. For this current, no problem. It is like V4 minus V5 over 5. For this current, it's like V4 minus V5 again, because it's between V4 and V5 over 1. For this current, I don't know how to calculate it, but I can take it to be equal to this current because they are connected in series. So, and this other current is what? This other current is V3
Minus V2.
V2 over 2 equals 0. So I'm taking, so in this one is simple. I didn't know this current, but I can take it to be equal to this single current. And this single current, it is V3 that is forcing current against V2. So that's going to be V3 minus V2 over 2. Multiply through by 10. I will have 2V4 minus 2V5 plus 10V4 minus 10V5 times 5.
Plus 5 plus
Plus 5
5V3
V3 plus 5
minus 5
minus
V3.
5 V2. And that will give me what? 0. Now, let's try to solve this. How many V4 do I have there? I have 2, I have 10, right? That's 12 V4. 12 V4. How many V5 do I have there?
That's
Minus 12 again, V5. How many V3 do I have there? Plus 5 V3. And then my what? V2 equals 0. So let's rewrite this. For the V4, I have this expression. So 12 times 4, that's 84. Plus 12 V3. For V5, this will be minus 12 V6. Minus 12 times minus 9.
plus 1
Plus 108. Plus 5V3, we are not getting rid of 5V3, we are not getting rid of 5V3. For the I2, I have minus 5. Minus 5 times this will give
That's
me
plus 7
plus 35,
plus 35
over
over
2
2V6.
V6. Minus 5 times that will give me minus 1.
Minus 135 over 2.
135 over what?
Over 2 is equal to
equals
0.
0. So, I've almost finished, Abby.
Yes, sir.
So, let me clean this, please. If I clean that, let me multiply through by 2. So, get rid of this will be what? This will be 168 plus 24 V3 minus 24 V6 plus 216 plus 10 V3
Plus 35 V6 minus
plus
135.
35 V6 minus 135 equals 0. Have I done it well?
Yes, sir.
I multiply through by 2. Let me remove this. Now arrange. Do I have V1 there? No V1. I can say 0 V1. Do I have V3 there? 24.
34 V3.
34 plus 34 V3. Do I have V6 there? Minus 24 plus 35. What is that? That's 11.
Yes, sir.
Yes, sir.
That's plus 11.
Yes, sir.
Plus 11. plus 11p6. And then minus 135 here plus 168. What do you have?
33.
Huh?
32.
32.
33.
33. That goes to the other side.
We have 2 and 6.
2 and 6, sir.
And turn it together.
That's minus 20. Okay.
249
Yes.
minus what?
60 minus 249.
Minus
249.
249. Thank you. Let me write it down here. V1 plus 34V3 plus 11V6 equals minus 249. This is my equation 6. Let me clean this. I can now change it to matrix form. I can write it as 0, 34, 11 into V1, V3, V6 equals, I have 249 there. Is it minus?
Yes.
Minus 249,
477
477
minus 24.
minus 24. So for this one, I'm going to have minus 60. I'm going to have
Minus
minus
72.
72
minus 103.
minus 103. For this one, I'm going to
0
have
minus
0.
3 minus 14.
I'm going to have minus 3, and I'm going to have minus 14. I can now remove all my equations. Sorry, I kept all of them on the board for us to fill them. Sorry, I asked you to write, not knowing that I will not need information from you. Thank you. Thank you for being there for me. Thank you for not letting me be alone in this my studio. Now, so as it is, we only need P6. We only need P6. So P6 is going to be, so this is going to be 0, 34, 11. It's going to be minus 60, minus 72, minus 103. It's going to be 0, minus 3, minus 14. Since we are looking for P6, we are going to replace this side. Minus 249, 477, minus 24. This will be 0, 34, minus 60, minus 72, 0, minus 3. So this is very easy because we have a line where we have 2 zeros.
Yes, sir.
I can just use that minus 60